Thank you. It's interesting to be back. Adam and I met up at actually a near-form meeting earlier on in the year, and that's when he suggested I give a talk. So, and things have developed since then. A little bit of background on me, as you can tell from the hair and so on. I've been around a bit, right back to the 1980s. I mainly worked in healthcare. Started at the Royal Marsden Hospital. That's the big cancer hospital here in London and Surrey. Where quite unusual, we developed our own applications, and I think some of my code that I wrote back in the 80s is still in use in the hospital. Then I became a management consultant to Shross, big project called the NHS-wide networking project, which happened just before the internet started to really take off, and that's when I saw all this happen. I thought, I want to be part of this. And since 1993, I've really specialized in nothing else but web and associated technologies. Again, primarily but not exclusively in healthcare. One of the things that I did a lot of work with is these guys. If you're in America and you need a blood test, pathology test, the chances are that this company, Quest, will do that test. And your clinician, your family doctor, will send the test request through, get the results and all the process through this application called Care 360. It's a web application, it's an Ajax application, and it runs on technology that I created. And even back in 2006, which is when it was launched, 30,000 concurrent users at peak times, gigabytes of data go into it. It's a huge application. Needs to be highly secure. You know, you've got personal information, you've got medical information, you've got stuff that could kill you. The liabilities on this, being an American company, are huge. So it's kind of scary sometimes to think that all of this is running on technology that I created back in 2006. It was something called EWD. So I've been involved with Node.js right from almost the very beginning. So I looked it up and discovered it was August 2010 I started dabbling with the stuff, and version 0.2 had just come out. And as Adam said, I gave one of the talks at the inaugural meeting here at LNUG in 2011. And so 6 years later, I want to talk about this thing here, having your cake, Node.js Cake and Eat It. So it's nothing to do with Brexit, having your cake and eat it or anything like that. This I think is achievable. Oh, and by the way, another indication of my age is that my laptop, you'll see, doesn't have a single sticker on it. I'm feeling very out of date. So I'm old school, very much old school. So a bit of kind of background to where I'm coming from with this talk. So Node.js, and you probably, well, hopefully all are aware of this. You know, with Node.js, everything executes in a single process. And so you might have thousands of users, tens of thousands of users, all doing stuff concurrently, and they're all in the one process. And the way that it manages to handle that is through these two things, non-blocking I/O and asynchronous logic. So, you know, the idea is that nothing must ever block the process, or everything grinds to a halt. And with asynchronous logic, you know, you fire off the request to a database or a web service, and it just carries on, and it doesn't wait for the results. It carries on, moves on to the next task. And then when the results come back, at some convenient point of interruption, it can, I've got the results, right, I'll carry on with that. So Node.js is effectively server-side JavaScript. But the interesting piece of history on this is that Ryan Dahl, who hopefully all of you are aware of Ryan Dahl, he is the guy who created Node.js back in 2009. He wasn't actually a big JavaScript fan. And he was creating this thing he was going to call Node, where he wanted everything to be in a single process and non-blocking I/O and so on. And he realized that this very kind of environment was how the browsers work with JavaScript. And he realized that Google at that time had open sourced the V8 engine. And so he said, I'll use that, and I'll use JavaScript as the programming language for this thing he was creating. So that's how really we ended up with Node.js. He didn't set out to create a server-side JavaScript environment. Now, asynchronous syntax isn't unique to Node.js. It's there in other languages as well, and non-blocking I/O. You can do it in probably most modern languages. Java, Python, they all have it available. And it's an ideal way of doing stuff where you need to make parallel requests out to resources, like files, external web services, and it just makes efficient use of the resources where it's appropriate. The unique thing about Node.js is that you have to use it, right? In the others, it's optional. In Node, you've got no option but to use asynchronous logic. The other interesting thing about Node, this is something that fascinates me, because I've been involved with all sorts of languages over the years. And in any one of those, you get real religiousness, as it were, and they'll do everything in that language. Whereas even Node's greatest exponents will always say to you, there are things that you should not do with Node.js. And these are the big two things that come up. And there's articles you can get, do a bit of Googling on this, and you'll see that these two things always come up. CPU-intensive logic, a big problem with Node.js, and complex database manipulation. Particularly if, like me, and it's the area I specialize in and have focused on, where you're wanting to do very high-level database abstractions. I'll not be talking a great deal about that in this talk, but we'll touch on it a bit later. So with CPU-intensive logic, the problem here is that if some work that one user is doing ties up the CPU, then everyone else is going to be blocked at that time. And one of the problems with CPU-intensive logic is that it's difficult to determine how CPU-intensive some of the stuff that you're going to do is. And some of it is inevitable. So if you're doing JSON web tokens where you're getting digest, SHA-256 digest and so on, anything to do with encryption tends to tie up the CPU pretty heavily. And if everybody is doing it, then you're going to potentially get in trouble. With database manipulations, you can end up with again, restrictions and awkwardness that is a result of the asynchronous logic that you're forced to deal with. And as I said, the thing that I have been working on is some very, very high-level database abstractions where you actually need chained synchronous functions in order to create that kind of environment. If you look at what most newbies, people coming new to Node.js, what their concern is, it's almost always, it's asynchronous logic. Am I going to be able to get my head around that? Most people probably do, but there are some who never really can get to grips with the asynchronous logic nature of Node.js. Now, of course, we've got this wonderful new thing in Node.js version 8, Async Await, and that's the big white hope. It's greatly improving the syntax that you need for this. We can avoid all that horrible callback hell that we used to get into, and gives you a very synchronous logic structure, and can tidy up the way code looks. And the previous talk, where we had all that live coding, I think you saw quite a bit of that style of logic in there. The problem with Async Await is that although it helps with the syntax, it doesn't really resolve these two other problems. It doesn't deal with Node.js concurrency, so you still need to avoid CPU-intensive code. You still need to know what code that you're writing is going to be CPU-intensive, and it still doesn't give you a solution around very high-level abstractions where you need synchronous chained functions. Now, the usual solutions that are suggested for getting around this involve offloading CPU-intensive work and using something like RabbitMQ0MQ, using other languages for the database. I've seen people say you should use Rails, for example. And the downside of that is that you then end up with this heterogeneous environment. You've got far more moving parts, you need a lot of different skill sets, and it's all starting to get more complex. Maintainability is starting to, lots of people involved. If a problem goes wrong, where in that is it happening? So it might be interesting to then look at, well, what does Ryan Dahl think about all of this? And as it happens, that paper, that the article that I wrote, which was published, I think it was 10th of August, this came out not long afterwards, the end of August, and I don't know if any of you have seen it. If not, you should. It's a transcript of a podcast done with Ryan Dahl, which these days is a very rare event. And I thought I'd pull out some of the things that he said in there, because they're pretty interesting. So he makes the point, within a single process, you should handle many requests by being completely asynchronous. And he believed strongly at the time, this is 2009, when he was developing Node.js, that that's the way it should be. But over the past couple of years, he's started to doubt that that's the case. And it turns out he's mainly working with Go now. He's moved on to Go. And in Go, they have abstractions. So even though he believes it's still non-blocking I/O, to the developer, in the kind of user land world, you don't think of it in those terms. You're writing apparently synchronous logic, and you've got these green threads at the interface between Go and the operating system that look after that. And this is kind of interesting. He says, I think Node is not the best system now to use to build a massive server web. I would definitely use Go for that. And honestly, that's basically the reason why he left Node. It was the realization that, oh, you can hear, if you know Ryan Dahl, you can hear him say this, oh, actually, this is not the best server-side system ever. What do I think? I want to have my cake and eat it. I actually like JavaScript. I've always liked JavaScript. It fits very well with the kind of work that I want to do. And I think, by the fact that you're all here, you probably all quite like JavaScript. So I don't want to use Go to do this kind of stuff. I only want to use one language. I want one skill set. I want one set of moving parts. I don't want all these extra technologies. I want to keep things simple. And I want to be able to use Node in a similar way, actually, to that way that Ryan is describing with Go, where I don't have to really think about, am I doing CPU-intensive code? If I want to use synchronous logic, I'll use it and figure out a way of abstracting that so that it's not my problem. So the problem with all of that comes down to this issue of concurrency, the fact that all concurrent users in Node.js share the same process, right? And I started to realize at the beginning of this year that actually Amazon Web Services have kind of accidentally stumbled on a solution to this. And I don't think they've even realized they've done this either. And it's this thing called AWS Lambda. Has anybody here used Lambda? Has anybody? A few people? Most of you are probably aware of what it is. If you really want to annoy people, you call it serverless. Strictly speaking, it's what's known as function as a service. The idea is that it's reducing, this platform independence right to the ultimate extreme, where all you write as functions, you upload your functions to AWS Lambda, and it figures out how and where to run them. You don't know or care what machine it physically runs on. You just want your function to run, and you'll be charged every time that function is invoked. And the first technology that they made available for AWS Lambda was Node.js. And if you start to examine how it actually works, you discover that when your function is invoked, it's actually running in a private container. And your function has that container all to itself. So there's no actual competition in that container when your function runs with any other Node.js logic. You have that exclusively to yourself. The interesting thing is that all the examples that you look at for AWS Lambda using Node.js still use asynchronous APIs. And And people even will use async await within those functions. But if you think about it, if your Lambda function really needs to be, if it doesn't really need asynchronous logic, why use asynchronous logic at all, given that you've got that container all to yourself? And going back to this issue about these other languages that have asynchronous logic in them, Java, Python, and so on, for the reasons that I talked about before, if you were writing in those languages, if you didn't have to use asynchronous logic, you wouldn't do it because it's optional. Right? I don't know of anybody who would, by preference, apart from the Node.js community, write asynchronous logic if they didn't have to. So the question that came to my mind then as a result was, well, why should we be using asynchronous logic in Lambda functions if we don't need to? And I think it's partly for two reasons. One is, well, that's what you do in Node.js, right? That's what we do. It's asynchronous logic. So why rock the boat if you don't, we'll stick to that. But I think mainly it's because of the nature of Node. There aren't any synchronous APIs, for example, for database access and so on. They just aren't out there because they've never been needed. Now, such APIs are possible. There's one here. In fact, the author is sat at the back there, Chris. Something called TCP-NetX. It provides a synchronous connector, TCP connector. And you could use this to create a synchronous API for accessing a database or files or whatever within your Lambda functions. And in fact, there's one such one here that Chris has done for MongoDB. It just provides a synchronous connector for MongoDB. So it's perfectly possible to create these things. So that's Lambda, but not everybody will want to use Lambda for everything they want. So the question then I had was, well, would it be possible to create something similar running in your own server, in your own local environment, that would create a similarly isolated container for the functions that you want to run within your Node.js environment? So removing concurrency as an issue. So for the past 6 years, I've been working up to this product here called QEWD. I've developed it along with a number of customers and so on. It's all open source, it's out there. And it's based on these principles of being able to have an isolated runtime container. So what I wanted to explain a bit about was how it actually works and how it becomes possible. So what is QEWD in general? I think the best description is a multi-purpose Node.js runtime platform. That doesn't tell you a lot, really, does it? But it's all about creating isolated runtime containers for your message handler functions, such that you don't really end up having to worry about CPU-intensive work. And it starts to allow you to use synchronous logic to do the kind of stuff that I want to do, which is very high-level database abstractions. So the way it manages to do this is fairly straightforward. There's a master Node.js process and a pool of worker processes. The master process handles all the incoming requests. It has Express or Core.js. You can decide which one you want as its HTTP REST interface, and uses socket IO for WebSocket interfaces. And it returns the responses back to the client. And that's all the master process does. Okay? All of the work is done in the worker processes. And a key thing is that a single request is dispatched from the master process queue to an available worker process. And so each worker process handles a single request. That queue dispatcher worker process pool management mechanism was all handled by a separate module called EWD QOperate. And it's used by QEWD, but it's actually a separate module, so it's available for people if they want to do this kind of stuff. You can go off and use this as the basis of your own mechanism. So here's the way it works. You've got incoming requests. They can be HTTP or REST ones. They can be WebSocket ones. And the request is immediately put on the queue. Okay, no further processing occurs. But as soon as a message goes on the queue, it triggers an event which causes the dispatcher to take the message off the queue and try and pass it to a worker process. And if none exist at the moment, it'll start one up. So that worker process starts up. It loads all of the queued specific logic that it needs to make it work, and then your application specific logic, any connections to databases and whatever. And the request is then passed to that worker. And here's the key thing, that worker then flags itself as unavailable, okay? So that the next incoming request to the queue, if that one's still unavailable, it starts a next one, all right? And that then becomes unavailable. And this will continue until your pool size, your nominated pool size is reached. In which case, any more incoming requests are simply queued and then handled once one of those workers becomes available. So the workers, and here's the other key thing, the workers are persistent. They don't close down, okay? So they immediately become available. You, in your function handler, your message handler that's running in the worker, you determine when it's completed, and you just fire this function called finished with a response object, and that is then sent to the master process and dispatched out through Socket.io or through the web server out to the waiting client. And it also tells the worker process that you are now available, okay? And so now it can handle the next queued request. Worker process, once they are started, are persistent, so this avoids the startup cost. And worker processes are quite expensive to start up. So this avoids that, they just get reused. Now, if you think about it, the master process is the ideal Node.js application. So 100% asynchronous, all the concurrency is handled in there. And it does virtually nothing. There's almost no CPU load in there at all. It just puts them on the queue and dispatches them out, returns the response when they get them. All the work is done in the worker processes. And they only handle a single request at a time. They're completely isolated runtime. They're only handling one request at a time. So you have no concerns about concurrency. You've got that entire process all to yourself, and you can safely use synchronous APIs. Long-running CPU-intensive logic, no, it'll have some effect, obviously, on the overall available resources within the machine, but it won't have any direct impact on any of the other worker processes or the master process. So, okay, a few questions then, that's all very well, but why not just use child process? And the answer is to avoid that very high startup cost when you start up a child process. They reckon that it's at least 30 milliseconds to start a child process. In a high-performance system, that's no good. You can't have that. Now, the workers in QEWD are child processes. Of course they are. That's how it works. But they keep running. So the only startup time is the very first time when you bring up the system, the very first request brings up, that's the one that gets the hit. After that, they're ready and available. Why not use cluster? That's the obvious way to do this stuff, isn't it? Well, cluster's all very well, but actually the way it works is it spreads the overall concurrency across a number of processes. So each one of those processes is still handling a whole bunch of concurrent requests. And if any one of those ties the CPU up, then everybody else in that clustered process will get held up as well. So it kind of gets you so far, but it wasn't the solution that I was wanting. So by forcing the child process to only handle a single request, then QEWD gives you this isolated environment, which is what I wanted to have. Why not use RabbitMQ or ZeroMQ? You know, why am I writing a whole queue system in Node? Well, it's because I wanted to only have one technology, one moving part, right? I didn't want this heterogeneous environment. And actually, when I was creating this in the first place, one of the things I did was I ripped apart the queue mechanism and put in 0MQ to see how that would behave. And I thought actually was going to perform a lot better. Actually, it gave no performance benefits whatsoever. I was really surprised about that. Maybe I was doing something wrong with it, but I did a lot of work with it, and I wasn't that impressed. And you know, it proved that no, you can use a single technology here, Node, and do all of this stuff just as well. Which begs the question then, well, what kind of performance can you get from this kind of environment? And I was talking to Adam about this at the microservices meeting, and it's kind of what I think triggered him to say, well, you must give a talk on this. So I decided, well, what's a good way of a good benchmark for this? And I decided, well, let's do it with a Raspberry Pi, you know, 30 quid's worth of kit. And the nice thing about the Raspberry Pi Model 3 Model B is that it's a four-core CPU. It's a nice little machine. And it means that we've got 4 cores to spread the load across, okay? With the master process and the workers. And it's easily replicable. That's a difficult word to say. So EWD QOperate comes with a benchmark script, which is what I've used here. You can run the same thing on a Raspberry Pi, and you should get exactly the same results, right? One Raspberry Pi is the same as another, as long as it's the same model. So the benchmark script allows you to say how many workers, how many messages in total. So I said, okay, 500,000. And it allows you to create a steady state. So instead of just creating, you know, bang, 500,000 into the queue, and since it's an array-based queue, that's not a good idea. It allows you to drip feed them in. So I set up, said, right, every 100 milliseconds, add 622 messages to the queue. And that created a steady state that it could deal with. The messages are very simple. It doesn't do anything. It just send them to the worker, and it echoes the response straight back. But on a Raspberry Pi, 30 quid's worth of gear, I was getting 5,800 messages a second round tripping on this thing. Now, they're not doing anything in the workers, but the limiting factor on the Raspberry Pi at least was the master process hit 100% CPU, so it couldn't go any faster. But the workers were only using 30% CPU. So if you think about a real-world environment, you've still got 70% of the CPU in those cores available to do real work in the workers while you're maxing out the master process. Now, I've tried the same benchmark on other machines. I've tried it on this thing here in a VM, where it was just a single core. And it starts to get a little bit different. You get that you can't reach 100% in the master process. And I think it's because you're getting limitations on the network, the internal networking, the IPC channel between the worker and the master processes. But that's something that other people may want to check out. So what can QEWD, this project that I've built on top of this stuff, what can it actually be used for? Well, I've developed it for a whole bunch of things. I like to abstract stuff away and make it easy for myself to use and for other people to use. So one way of using it is a full stack platform, a bit like Meteor actually. It's got built-in WebSocket Ajax messaging. It's all automated. You really don't have to know much about either of those, but you can seamlessly swap the transport. You can write the application using WebSocket and say, no, I want to use Ajax without any code changes. It'll use Ajax over HTTP instead for the messaging. Obviously, with WebSockets, you can do bidirectional flows, as was demonstrated earlier, which you lose on Ajax. And security within this environment is all built in and automated for you. It can also be used as a REST API server. It's got session management built in if you need to use that. All automated, token-based, with server-side persistent JSON storage using that high-level abstraction that I've created. It's also got a mode where you can say, I want to use JSON Web Tokens instead, so it's all done on the client instead of the server. Again, all automated, all built in, and you can run it as an API, REST API server and an interactive server at the same time. It can be used as a microservice platform. This came out of the result of that meeting that I went to. And with this, by using shared secrets, you can use and JSON Web Tokens, you can then spread the load across multiple QEWD servers. So you can create a fabric, as it were, of QEWD servers and separate out the work as microservices. And these communicate over WebSockets, so just using socket IO. And if you're running that over HTTPS, it means that, again, you're not constantly opening and closing HTTPS connections. Once they're established, then they just keep running very, very high performance. It can also be used as a federation platform, so where it provides a middle tier to multiple REST servers behind it, and it allows you to send one request in, fire off multiple requests to the back-end servers, pull them back together, or create what I call a dance, where you send a request to one, and as a result of that response, you send another request to that guy and another one to that, and you gradually build a composite response. There's an application where I'm involved in using something called OpenEHR, a healthcare application that does exactly that, uses back-end servers known as OpenEHR servers, and QEWD provides the middle tier to pull all of that clinical data together. The idea here being in a clinical application, actually, as I was saying to this chap here earlier on, through life you leave data, healthcare data about yourself all over the place. You know, when you go to your GP here and you move house to another GP, you go to that hospital and you go to this hospital. And one of the big problems in healthcare is being able to pull together all of that composite information so that if you turn up in A&E with a problem, that they know that they mustn't give you penicillin because it'll kill you, or the reason why you're here is probably because of this past history and this kind of thing. And to be honest, at the moment, that's very difficult to do. So this is the kind of application that's going to allow that to happen. It can also be used as an interface to a style or class of database that probably none of you are aware of. It's known as a global storage database. There's a number of these. There's one called GTM, and also a new variant of that called YottaDB. There's one called Cache, with a new platform coming out called Iris. We've got a chap called Mike Fuller at the back here who can tell you about Cache and Iris if you're interested. I've done an emulation of this style of database using Redis. And all of these are then abstracted within QEWD as two things, what I call persistent JavaScript objects. So you're dealing with objects, they appear to be objects, but they're actually manipulating data on disk instead. But also as a fine-grained document database. So unlike Mongo, where the document is the unit of storage, with this, the unit of storage is actually the individual name-value pair within any level of an overall JSON object. It's a pretty powerful database concept. Although QEWD, the QEWD QOperate queue is an in-memory queue, you can also have an optional resilient mode where it backs up the queue to the database, one of these global storage databases, such that if it goes down, when you bring it back up, it'll replay any unprocessed messages, and so it keeps the thing resilient. It supports all JavaScript frameworks, but there is some pretty cool tooling, a third-party stuff. There's a guy I work with a lot in Belgium is using it for a retail site, and he's been doing a lot of work with React and Vue with QEWD, and he's also using the microservices stuff to pull together stock information between their various stores across Belgium. So that's what QEWD is all about, and the idea, and hopefully I've explained it to you such that you realize it is true. Yes, you can have your Node.js cake and eat it too. If you're interested, have a look, QEWDJS.com. There's a load of tutorials that I put together. They're all on SlideShare. It's a big menu. Go through you'll see all the stuff about the database and all about how it works. Give it a try.
Thank you, Rob, for that.
You're welcome. Thank you.